lesson 6-1, rate of change and slope. Rate of change is a relationship between two quantities that are changing. The rate of change is defined as the change in the dependent variable over the change in the independent variable. If you remember, the dependent variable is y and the independent variable is x. Slope is the measure of the steepness of a line, and it's very much related to the rate of change. The slope of a line is its rate of change. The slope is the vertical change over the horizontal change, and often it's defined as the rise over the run. Now, you can find the rate of change by looking at a table. If I have a table and I want to figure out the rate of change for this table, the first thing I need to do is I need to make sure I understand which variables are the dependent variables and which variables are the independent variables. If you remember, x always comes first and y always comes second. And x is always the independent variable, and y is always the dependent variable. So miles in this case is independent, and phi is dependent. We want to figure out the rate of change. Rate of change is found by taking the change in the dependent variable over the change in the independent variable. So the first thing I'm going to do is I'm going to look at my dependent and independent variables. And I'm going to look at them in pairs. Here's one pair. Okay. I'm going to look at this pair of numbers, and I'm going to see how does the dependent variable change and how does the independent variable change. To figure this out, I'm simply going to look at the dependent variable. I have 30 and 42. So if I was to look at how they changed, I could say 30 minus 42. And the independent variable changes as 100 minus 150. I could do it the other way around. I could do 42 minus 30 over 150 minus 100. I would get the exact same answers. Here, if I take 30 minus 42, I get negative 12. And 100 minus 150, I get negative 50. And a negative divided by a negative is a positive. I can divide both of these things by 2, and I get 6/25. If I did it the other way around, I would have 12 over positive 50, which still reduces to 6/25. That is the rate of change for these two numbers. But I need to compare the rate of change of all of the pairs of numbers. So now I need to see the rate of change between these two numbers. So instead of 130 and 150 and 42, I'm now going to look at 150 and 42 and 254. So if I look at those numbers, if I did 42 minus 54 over 150 minus 200, I will get 42 minus 54 is negative 12, and 150 minus 200 is negative 50. So again, this is 6/25. And last but not least, I need to look at the last pair of numbers, which is these two, which I'm just not going to highlight at this moment. I'll leave them unhighlighted. So this particular pair would be 54 minus 66 over 200 minus 250. 54 minus 66 is negative 12. 200 minus 250 is negative 50. So again, this is 6/25. So we have a constant rate of change. Okay. That's what this question is asking us. From the data in the table, is the rate of change for each pair of consecutive mileage amounts the same? Yes, it is. It's 6/25. So our rate of change is 6/25. But what does this 6/25 mean? Well, the 6, okay, the 6 over 25, the 6 stands for the phi, and the 25 stands for the miles. So essentially what this means then is the fee will be $6 for every 25 miles. So the rate of change is $6 per 25 miles. So for every 25 miles I drive, it will cost me an extra $6. That's the rate of change. You can also find the rate of change from a graph, which is slightly easier than finding it from a table. All you need to do is you need to find 2 points that are on your graph that lie exactly on a coordinate point, not a fraction between a coordinate point. So I would highly suggest that you copy both of these graphs into your notes on a piece of graph paper. If you want to graph these easily, this first graph, the graph on the left, this first point here is negative 2, 0. And another point to graph would be 0, 4. If you graph those 2 points and make a straight line, you'll have the same exact graph I have here. I'm going to erase those data values for the moment because I need to reuse the graph and they get in the way. When we read from left to right. So as we go along, left to right, we should go along until we hit a point. I've hit this point right here. From that point, we want to determine the slope. And slope is determined by how much does the thing rise over how much does it run. So if I'm going from left to right, as I read, I notice I'm going to have to go up this many units. In this case, I have to go up 2 units. And I have to go to the right 1 unit. And that will stay consistent. The next time to get from this point to the next point, I go up 2 units again. I go to the right 1 unit again. So my slope for this particular line is 2 over 1, or just 2. When you deal with slope, you either leave it as a whole number or you leave it as an improper fraction. You never, ever, ever change it to a mixed number. Slope is never put in a mixed number. It's always in the most reduced fraction as an improper fraction or as a whole number. And if we look at the next graph, as we read from left to right, we start here at this point negative 3, 2, but instead of going up, we're going down. So instead of going positively, we're going negatively. So our slope is going to be negative in this particular case because we're going down and then we're going to the right. We go down 2 units and then we go to the right 4 units. So my slope for this particular graph is negative 2 over 4, which would reduce to negative 1/2. So my slope is negative 1/2. Slope is for a graph is just found by finding 2 points that lie directly on the graph and on a coordinate point, and you're either going to go up and right or you're going to go down and right. If you're going up and to the right, you have a positive slope. If you're going down and to the right, you have a negative slope. Notice in the graph to the left, I am climbing up. As I read from left to right, my graph is going up to the right. On this graph to the right-hand side, as I read from left to right, I'm going down to the right, so it might have a negative slope. Sliding down, climbing up. Up is a positive slope, down is a negative slope. We can also find the rate of change from a set of points. If you don't want to have to graph every blessed thing you do and then read it off of the graph to find slope, finding slope using a set of points is much easier. To find your slope from a set of points, you're going to still do rate of change, which is your vertical change over the horizontal change, which some books define as rise over run, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x sub 2 and x sub 1 cannot equal 0. I mean, don't get all confused with these little subscript things. These little subscripts right here, all they mean is y sub 2 means the y value of the second coordinate. Y1 means the y value of the first coordinate. X sub 2 means the x value of the second coordinate, and x sub 1 means the x value of the first coordinate. So don't let the little subscripts fool you. Now, rise over run. I can do this. I could do y1 minus y2 over x1 minus x2. That is perfectly fine. The formula can be written as, you can rearrange the y's and you can rearrange the x's, but you cannot mix them up. You can't do y sub 1 minus y sub 2 over x sub 2 minus x sub 1. This is very, very bad. Don't do it that way. If you choose to have y1 come first on the top, you have to have x1 come first on the bottom. If you have y2 come first on the top, you must have y2 come first on the bottom. All right, now we're going to find some slopes using points. Okay. The easiest way to find the slope between 2 sets of points is to write them write them vertically. They're already written here horizontally. I'm going to write them vertically. The reason I write them vertically is now my x values line up and down, and my y values line up and down. So I can look right here and say, okay, there's my x values, here's my y values. These were my x values, these are my y values. So I can very easily figure out the slope of my points by using the change in y over the change in x. I have a tendency to like to go from the top to the bottom, so I'm actually going to use y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So to find my slope, okay, the slope is abbreviated with the letter m. I'll explain why in just a minute. Find my slope of this particular problem, I need the change in y, 2 minus 9, over the change in x, 2 minus 8. 2 minus 9 is negative 7. 2 minus 8 is negative 6. A negative divided by a negative is a positive. So my slope here is 7/6. We do not change it to a mixed number. I talked about that before. You reduce it to lowest terms. You never, ever change it to a mixed number. Now you might ask, why in the world do we abbreviate slope with an M? Slope is an S. Well, slope was not invented and was not determined by English-speaking mathematicians. The coordinate system is often called the Cartesian coordinate system because it was explored by a Frenchman named René Descartes. So they named it after him. Since he was French, the French word for slope is montier, which starts with an M. It means to mount, so therefore they abbreviate slope with an M. Makes perfect sense to the French, doesn't make a lot of sense to the English because we kind of think we're a little self-centered and think the whole world revolves around us. We need to get out of that habit because there are a lot of mathematicians who are not English. All right, let's look at problem number 2 here. -1, 4, and 3, -2. Again, I'm going to rewrite my problems so that they are one on top of each other so that I can line up my x values and I can line up my y values. So here I go. I'm going to find my slope. My change in y over my change in x. So I'm going to do 4 minus a -2, beware of your negative signs, over -1 minus 3. The most common mistakes people make when dealing with slope, they either have the formula upside down, they interchange their x's and y's, or they don't pay attention to their signs. So pay attention to your positive and negative signs. 4 minus a -2 is actually 4 plus 2, which is 6. -1 minus 3 is a -1 plus a -3, which is -4. I can reduce this to become -3 over 2. So my slope for the second set of points is -3 over 2. Again, do not change it to a mixed number. These next 2 problems. All 4 of these examples should be in your notes because all 4 of these examples are very, very important. If you didn't write them down, go back and write them down again. Here we go, 4, 2, and 1, 2. I'm going to rewrite these. I'm going to stop highlighting them because hopefully now you know that x comes first is on the left and y comes second on the right. I'm going to find my slope of this particular set of points. 2 minus 2 over 4 minus 1. 2 minus 2 is 0. 4 minus 1 is 3. If I have a 0 on the top, that means I have 0 things that I'm going to divide between 3 people. Each person gets nothing. Okay, so my slope here is 0. What does this exactly say? Remember, slope is determined and defined by rise over run. So what this is saying is I'm not rising at all and I'm only running. I'm rising 0 units and going 3 units to the right, rising 0 units, going 3 more units to the right, rising 0 units, going 3 more units to the right. In other words, I'm constantly going to the right. I'm constantly running and never rising. Because of that, there's a special, this is a slope of, a line that has a slope of 0 is a special type of line. If I was to put on an x and y axis, the graph of a line that always runs and never rises, it would be a horizontal line. That's the graph of a line that always runs and never rises. So if something has a slope of 0, it is a horizontal line. Let's take a look at this last problem, 4, 2, and 4, -1. Again, I'm going to line up my numbers so that I don't get confused. My slope says change in y, 2 minus a -1, over my change in x, 4 minus 4. 2 minus a minus 1 is actually 3. 4 minus 4 is 0. If you were to put that in your calculator, 3 divided by 0, you will get either error or it'll say undefined, division by 0 is not defined. Okay. Therefore, when we have division by 0, this slope is what we call undefined. Remember, in the previous problem, a slope of 0 over 3 says I have 0 items, I'm going to divide them between 3 people. Each person gets no items. That's reasonable. Here, I've got 3 items and I'm going to divide them between nobody. Each person's going to get, I have nobody to divide them between. You can't divide them up between people that don't exist. Therefore, it is undefined. By the rule for slope, or the definition of slope, this is rise and this is run. Which means a line that is always rising and never running, if I was to graph this, a line that is always rising and never running is a vertical line. I'm always going up and down, and I'm never going left and right. Okay? Always rising, never running is an undefined slope, and it's called a slope of a vertical line. Okay. So here we have slope. We've determined how to find the slope from a table of values, find a slope from a graph, and find a slope from a set of points.